Lesson 2 in our series on dividing fractions deals with how do we move from looking at modeling of the dividing by fractions to using standard algorithm. Because as you've learned through our other three computations, using the standard algorithm always is faster and more efficient than modeling math every time we need to. In order to use the standard algorithm to find what answers are for dividing by fractions, we got to understand this term called a reciprocal. Okay? A reciprocal are numbers that are just representative of inverse relationships. We know that inverse kind of means the flip-flop. Like addition is the inverse of subtraction, subtraction is the inverse of addition. We've also learned through whole numbers that multiplication is the inverse of division, division is the inverse of multiplication. We're going to use this idea of inverses with reciprocals. So for example, the reciprocal of 4 is 1/4. That's because we know that any whole number, if we put it in fraction form, can be considered to be put over 1. So when we take the inverse of 4 over 1, that's 1/4. Likewise, the inverse of 15, the reciprocal of 15, is 1/15. We just take the numerator and the denominator, we flip it. The inverse of 3/4, the reciprocal of 3/4, is going to be 4/3. Now, you'll notice that means this becomes an improper fraction, or really a fraction that's going to have a whole number part. That's okay. That's okay. Because we're only going to use the reciprocals when we're trying to calculate a quotient through division. The relationship that exists with reciprocals pretty much says that 7 divided by 1/4 is the same thing. It's equivalent to saying 7 times 4, because 1/4 reciprocal is 4 over 1, which is 4. And in both cases, these come out to 28. Now, we could pause here and we could model what 7 divided by 1/4 is using modeling based on the last video, but I'm pretty sure you guys are going to take my word for it. So what we're going to do is we're going to look at the problems that we used in the first video to model, and now we're going to use the standard algorithm and reciprocals to solve, just to show you how easy it is. Oh, I got a challenge too at the end. If the reciprocal is just flipping a number on top of itself, like 4 becomes 1/4, 15 becomes 1/15, 3/4 becomes 4/3, what does a mixed number become? 2.5. Take a moment to figure that out, pause the video, and at the end of the video, we'll talk about that. So let's look at the first example from the first video. We want to take one whole and divide it by 1/10. Yesterday we modeled one whole roll of hamburger split into 1/10 pieces, means I could get 10 wholes. We proved that the answer was I could get 10 dinners out of one large roll of meat if I split it into 1/10. Now on the math end of that, what this looks like, I'm going to come back to the equation that we wrote. 1 divided by 1/10 we know equals 10. But now if I want to model it, the relationship that exists is we take the inverse of the number and we take the inverse of the operation that we're working on. So 1, the inverse of division is multiplication. The reciprocal of 1/10 is 10 over 1, which is just 10. Okay? And that equals 10. If we did put 1 over 1 to make a fraction, we know that fractionally, numerators times the numerators, denominators times the denominator, that would give us 10 over 1. 10 over 1 is 10. So there's our proof. Okay. Now, let's look at the next one we did. That was the one dealing with going on a walk and doing push-ups. 5 divided by 1/2. Shockingly, that one came out to be 10/2. Alright? So when I got 5 divided by 1/2, that's the same as taking 5 multiplied by that reciprocal. Flip-flop 1/2, That becomes 2 over 1. I can put 5 over 1. You never take the reciprocal of your dividend. Just the reciprocal of your divisor, what we're dividing by. 5 times 2 equals 10. 1 over 1 is 1. 10 over 1 equals 10. That was some of the relationship that we started to recognize yesterday when we were going through the modeling. 1 second. So now let's look at one without the modeling. Brand new problem. Let's go with what happens if we have 6. We did 6 in the Thanksgiving problem. Let's not do that. Let's do 8 divided by 3/4. So if we want to take 8 and divide it into 3/4 segments, how many segments would that be? To solve, all we do is we leave our divisor, our dividend alone, our dividend, the one we're dividing, and then we take our divisor and we take its reciprocal. 3/4 splits over to, flips on itself 4/3, and the inverse of division is multiplication. Whole number over 1. Numerator times the numerator, denominator times the denominator. 8 times 4 is 32. 1 times 3 is 3. We could leave it in this form unless we're trying to put it in its reduced terms or simplest form. We know that 32, 3 goes into 32 10 times with 2 left over for 2/3. We can turn it into a mixed number. Now the challenge problem earlier, we said what would be the reciprocal of 2.5, and it relates to what we just had to do this last step. We can't take a reciprocal of a mixed number as it is. We've got to change it into a fraction first. So 2.5 as a mixed number becomes 5/2 as a fraction, which means its reciprocal would be 2/5. If you had 2/5 as your reciprocal for that number, virtual high five. Next up, we're going to talk about what happens when we divide a fraction by a whole number.